aircraft's path along the different axes is controlled via primary and secondary flight controls. In this lesson, we will be going through the primary flight controls and their impact on the attitude of the airplane. The different parts of the aircraft are known as the wings, the tail section, the nose section, and the landing gear. The tail section is often referred to as the empennage, and from the tail forward is known as the fuselage. The aircraft can rotate around 3 different axes. We can roll the aircraft, we can pitch the aircraft, and we can yaw the aircraft. The pilot uses the ailerons, which are located on the trailing edge's outer portion of the wings, to control the roll motion. The pilot would roll the airplane about the longitudinal axis, which runs from nose to tail. He can also pitch the plane around the lateral axis, which runs from wingtip to wingtip, by using the elevator to push aircraft up or down. The elevator is located on the trailing edge of the horizontal stabilizer. And finally, the pilot would use the rudder to yaw the airplane around the vertical axis, which passes from top to bottom straight through the aircraft. The rudder is moved right and left using the rudder pedals and is located on the trailing edge of the vertical stabilizer. These are the 3 primary flight controls which you should be knowing during your training. But as mentioned earlier in the lesson, we have 2 types of flight controls. Then what constitutes the secondary flight controls? Secondary flight controls on our training aircrafts are 2 flaps and trim tabs. The flaps are located on the trailing edge's inner side of the wing, whereas the trim tab is located on the trailing edge of your elevator. Some airplanes are also equipped with a rudder trim, which would be attached to the trailing edge of the rudder. Other flight controls, such as spoilers that you may find on large airliners, would be considered as a secondary flight control as well. In addition, slats are aerodynamic surfaces on the leading edge of the wings of a fixed-wing aircraft, which, when deployed, allow the wing to operate at a higher angle of attack. They are usually used while landing or performing maneuvers which take the aircraft close to the stall, but are usually retracted in normal flight to minimize drag. They decrease stall speed. When deployed, the slat opens up a slot between itself and the wing. Now, how you control the secondary flight control from inside the cockpit does vary. Typically, the elevator trim tab, which controls your pitching movement, will be adjusted using the trim wheel as shown on the screen. Some airplanes are equipped by an electric trim tab, which is attached to the top of the yoke. The purpose of the trim tab is to stabilize the pitch of the aircraft and decrease the pressure on the controls during climbs, cruise, and descents. Back to the flaps, we have 4 positions which can be selected in order to position the flaps for a certain part of the flight. During takeoff, with plenty of runway available with no obstacles ahead, you would opt for a flapless departure. Whereas during a departure from a short runway, you may have to consider selecting the first step of the flaps, which is flap sten. During an approach, you will in most cases land with full flaps, depends on the runway available. However, in case of a large crosswind, gust, or an engine failure on a multi-engine aircraft, you'll have to select 1 step less than the full flap configuration. Secondary flight controls are there to help you decrease the workload and assist the pilot to maintain a stable and smooth flight throughout all its phases, so don't be shy with your input on these flight controls and use them as necessary as possible. Now, since we have covered up the primary and secondary flight controls, we will go through the deflection of each control surface and its effect on the attitude of the aircraft. As introduced earlier in the video, the ailerons contribute into the rolling motion of the aircraft. Rolling to the left would be initiated when the left aileron deflects upwards and the right one downwards. The upper motion of the aileron on the left wing decreases the angle of attack of the wing, whereas the downward deflection results in an increase in the angle of attack of the right wing. The exact opposite happens while turning to the right. The second primary flight control is the elevator. Pulling back on the yoke will deflect the control surface upwards, resulting into a decrease in the angle of attack at the tail and pitching the nose up. Pushing forward on the yoke would result in the exact opposite. However, the rudder is no longer controlled via the yoke. Its deflection depends on the inputs applied on the rudder pedals. Pushing left on the rudder pedal will make the nose of the airplane yaw to the left, while pushing on the right pedal will make the nose of the aircraft yaw to the right. Moving on to the flaps. As the most well-known secondary flight control is extended, the nose of the aircraft rises up because the resulting downwash increases the airflow over the horizontal tail. Therefore, the nose sinks down as the flaps are retracted, whether during maneuvers or after takeoff. To summarize, you should be able by now to distinguish the difference between primary and secondary flight controls and outline the output of each control surface. Relying only on the primary flight controls for the entire flight can be possible, but in order to ensure a smooth and comfortable flight, you must take full advantage of the workload decreasing devices, which are the secondary flight controls, whether you're flying an airliner or a training aircraft.